All right, so we are dividing polynomials. It is just like the long division problem you saw in class and that hopefully you remember from the 3rd grade. All we're doing is using polynomials instead. So here's our division problem. And so we're just going to follow the same exact steps that we follow when we do regular numbers. I'm going to see how many times x goes into 2x squared. Well, it goes, I said squared, 2x cubed. It goes in 2x squared times. And then I just multiply. So 2x squared times x gives me 2x cubed. 2x squared times 2 gives me 4x squared. And now I'm going to subtract that whole thing. So you may want to look at it this way. Some of you may prefer to not put the parentheses and put a minus sign here and here. Either way, I need to make sure I recognize that I'm subtracting this whole thing. So 2x cubed minus 2x cubed gives me 0, but 7x squared minus 4x squared gives me 3x squared. And just like we do with numbers, we're going to bring this piece down. So now I've got 3x squared plus 7x. So I'm going to see how many times does x go into 3x squared. Well, x times 3x gives me 3x squared. 3x times x is 3x squared. 3x times 2 is 6x. And again, I subtract this whole thing. 3x squared minus 3x squared is 0. 7x minus 6x. And you may prefer to view it like this. You may prefer to say, okay, I'm subtracting all of this. Either way of showing it, this way or this way is fine. Get an x right here. 7x minus 6x is x. I'm going to bring down this piece. And I've got plus 2. So how many times does x go into x? Once. 1 times x is 1x. 1 times 2 is 2. And when I subtract that, I get x minus x is 0, 2 minus 2 is 0. So this division problem has a remainder of 0. In other words, x plus 2 divides perfectly into this big polynomial. That means x plus 2 times this gives me this. So I can rewrite it as x plus 2 times 2x squared plus 3x plus 1. This right here is just another way of writing this whole big polynomial. And the cool thing about this is that now we can ask ourselves, is this piece factorable? So this x plus 2 is just going to stay here. Could I factor this? Well, a lot of different ways to do it. I'm going to use guess and check. I'm going to see, is there a way for me to set this up where if I multiplied 2 binomials together, I would get this trinomial? Well, the only way to split up 2x squared is going to be 2x and x. And then I'm going to ask, all right, what are my possibilities for a positive 1? Well, plus 1 and plus 1. And I see here 2x times x is 2x squared. 2x times 1 is 2x. 1 times x is x. 2x plus 1x is 3x. 1 times 1 is 1. So now I have fully factored this polynomial right here. Just like in the 3rd grade, you started out with just division problems. Your teacher just gave you division problems. That's how we're starting out. I just gave you a division problem and said, divide this. Once you did, then you were able to look at this piece and say, could I factor it further? And we saw that we could. So later on, you're going to get just this polynomial and I'll say, factor it. Right now, I'm still giving you a division problem. Just like it wasn't until the 5th grade that your teacher started giving you just like, here's 168, make a factor tree. Whereas before, your teacher was giving you specific division problems. We're still on the stage in the process where you get specific division problems. So we're going to stick with this problem and just see why the division was a helpful strategy. Imagine we don't have any of this. Imagine I don't give you a division problem and I say just factor this, and you get nothing else but the polynomial. That's all you've got. You might think, let me try to factor it by grouping. So you're going to look at these two groups. You'd say, all right, well, I could factor out an x squared in this first one, so x squared times 2x plus 7. The second one, I can't really factor out anything except a 1. 1 times 7x plus 2. And you're thinking, that's a parenthesis, it's kind of ugly. Oh, you can't see it, that ran off the page. 7x plus 2. And so now you're asking yourself, can I do anything with this? No. This and this, they're not the same. Factoring by grouping is not going to work that way. So, okay, forget that way. I'm going to try a different way. What if I decide to reorganize this polynomial? I like these two coefficients and the 7s to go together. I'm just going to rewrite it in a different order. So I'm going to put 2x cubed plus 2, just moving this 2 next to this one, plus 7x squared plus 7x. Okay, now let me try factoring by grouping. Take out a 2. X cubed plus 1. Here I could factor out a 7x. And I get x plus 1. These are still not the same. So I cannot factor this by grouping. I'm at a dead end. The only way I was able to factor it was because I gave you a division problem and said, divide like this. Once you had done that division problem, then you were able to keep factoring. So that's just to show you why we're doing division. Because in the past, we might have written, like for our first test, we might have written that this one was unfactorable because none of the strategies we had available to us worked. But we're getting new strategies now. So we're going to do another division problem, which is 2x plus 1 is being divided into 2x cubed plus 13x squared plus 16x plus 5. So just like we did our numbers, how many times does 2x go into 2x cubed? It goes in x squared times. X squared, oh, you can't see that 2x, can you? There. So how many times does 2x go into 2x cubed? X squared times. X squared times 2x is 2x cubed. X squared times 1 is x squared. Subtract it all. 13x squared minus x squared gives me 12x squared. Bring down the 16x and just continue the process. 2x goes into 12x squared, 6x times, because 6x times 2x is 12x squared, 6x times 1 is 6x, and I'm subtracting this whole thing. 16x minus 6x is 10x. Bring down the 5. I ask how many times 2x goes into 10x. That's 5. Because 5 times 2x is 10x. 5 times 1 is 5. Subtract that and I get 0. Since I have a remainder of 0, I know 2x plus 1 is a factor of 2x cubed plus 13x squared plus 16x plus 5. So that means that this is an equivalent form, 2x plus 1 times x squared plus 6x plus 5. That is equivalent to this big polynomial right here. And I just ask myself, once I've done this much, I ask, is this piece factorable? Because if it is factorable, then I could keep going. And I ask, are there any factors of 5 that would add to make a 6? Yes. X plus 1 times x plus 5. And so that is my fully factored form. Now the question that was asked here is, divide this polynomial by 2x plus 1. We did that right here. That's the answer to that. But the cool part about finding that answer is that then you can say, hey, now that I've got this piece, can I keep factoring it? So this division is a tool to get here, where you factor the whole thing out.